What's up, guys? I've got two annoying people here. That's why I haven't been able to finish this. What did Alright, so this machine, it's got a short circuit. So our main power is starting from here. I've already figured out what's the issue anyways. So we've got our main power our charger coming in from here. Via those inductors, popping up here via these inductors, and then first in rush, second in rush. Oh no, actually it's first in rush and then second in rush. So I've got the first in rush limiter, second in rush limiter, main power. Anyway, so checking for a short, I put one probe to ground over there. As you can see, we've got a 0 reading over there. So right over there, I'll try to pull it up. We've got a 0 reading over here. Reading over here, I've also got a 0 reading. So we've got a short circuit over here. Therefore, we are left with no choice but to inject voltage. So I'm gonna pull the clip up so that I can be able to bring the thermal camera or my phone actually. So I've hooked up the DC input on ground, and it's coming from a short killer. So this is the device I'm using, the short killer. It's set to 2.2 volts. So we're gonna inject voltage. One of the sides is okay, so this is the ground side. Then we'll come to the positive side. Let me grab something to. I hope this phone has got enough juice. Otherwise, we're gonna have trouble. Plug it to the charger and then I can check. Okay, so I'm gonna open the thermal camera right over there, and then we can inject voltage. So I hope you guys can be able to see. I've got a spot right over there. So at 150 degrees, that is shorted capacity, I'm sure. Okay, so I'm gonna apply the paste over there. Then I'm gonna inject. So you can see it's melting right over there, and it's even smoking. So it's this capacitor over here. That's the one that's faulty. Let me zoom in closer. So the last capacitor over there, you can have a look at it. Injecting. You can see it's even smoking there. That's our dead component. So theoretically, if you keep it like this for long enough, the short will just die out. The capacitor is just going to explode itself. But anyways, since you already know what's faulty, it's best to just remove it. So I'm going to fire up the water station and remove the dead component to make life easy for me. Okay. There we go. That is our dead component over there. So I'm just gonna tell you guys, this laptop didn't come in as a dead laptop. It didn't come in with a short. This short happened here as I was working on the device. No, not as I was working on the device. When I was done already, when I was closing the laptop. I don't know what's happening, but it seems like this photo is not hot enough, or something funny is happening. Oh, it's possible that the cap has riveted itself to the ground. So there you go. Okay, so here's our dead cap. You can check for that short, and it's gone. There's no short anymore. So here's the multimeter over there, and I'm gonna check for a short right over there where we were checking it initially, and we still have our ground and we've got our positive, so we don't have a dead short anymore. So all things considered, I would say that's fixed. Let me grab a similar port to replace that. Well, I've got the same port, not similar port, the exactly same port. The reason why I have it close by it's because this laptop was in for BIOS, and I did the BIOS on it. So I didn't actually program it. All I did was to swap the BIOS ICs from this dead motherboard to the working motherboard, and then the ones from the dead motherboard I put them on the working one. I think I've just repeated the same statement. Anyways, yeah, you get the point. So I'm gonna remove the cap here from here, going there. This should be quick. It should be quick enough. So there we go. That is sorted. So we can still check for that short. Make sure that we didn't replace a dead component with a dead component. Yeah, we still don't have a short, so we are sorted out now. Okay, so I'm gonna put back everything. So as you can see, I had removed the CPU because I didn't want to have anything which might cause the CPU to die. Yeah, you're injecting voltage on a power rail, which has to do with the CPU. Yeah, there you can see it's one of the phases to the CPU. So if maybe the MOSFET is dead and you force the power to flow through, you're gonna burn the CPU. So it's always wise, if you can remove it, remove it. If you can't remove it, isolate the short. Make sure maybe you remove the inductors so that power does not flow to the CPU in case there's any shorted MOSFET. So now I'm gonna assemble the laptop. I'm actually working on an assumption that this is fixed. I'm not assembling for now. I'm not so sure actually. With a short like that, it might as well have gone through the process. So I'm just gonna put the necessary screws. For example, these two. To bring these I/O ports together. The I/O port together with the main. I need that screw which comes here to hold the hinge. Now, this is what caused the whole issue actually. Now I can see. That's what I was saying I was going to explain. So this laptop actually had this plastic on top of it. So as you can see, what I just did when I screwed this panel in, you can see when I was screwing this screw in, this came into contact with the motherboard, causing a short, and that is why that capacitor exploded. So I was lucky enough that the short happened on the main power rail. If it happens on the main power rail, you can always fix it. But if you've got a short which is now on a secondary power, or like a 3.3 volts, 5 volts, 1 volt, or whatever, the issue with that is that you probably bent something along that line, say maybe the PCH or whatever, or the EC. Anyways, so always if there's a plastic protecting the motherboard, make sure you put it back. I was lucky, you might not be. So I'm gonna plug in the screen over there. I need the heatsink for the CPU, otherwise we will fry this thing. Alright, so now I need screws for the CPU. Where did I put them? There they are. Just twist enough, as long as they are diagonal. Okay, the RAM which I was using, I think is this one, and then that slot. So I'm going to plug it to the power now. And I believe it's on now. Yes, it is. Wait for the display. It's drawing 800 milliamps, and there we go. Yeah, my screen is dead. I just use it for testing. So yeah, the machine is on and it's working fine. So all we had to do was to replace that dead capacitor over there, and that was it. So the main issue was that make sure to replace the plastic if there was any protective material for the motherboard. Make sure you replace it. And yeah, I hope you learned something as always, and I will see you on another video. Cheers guys.